Question 13 of the May 2018 AS Paper 1 Edexcel. So we've got an equation here, and when you look at this graph here, it looks like a straight line graph, but notice that it says log to the base 10 of v on the y-axis and t on the x-axis. Okay, so obviously, well, hopefully it's obvious that this is not a graph of this function here. Okay, this is an exponential function, and if we did draw it, it would probably look more like this, curved. Okay, so the reason that it doesn't look curved is because what's being plotted on the y-axis is log to the base 10 of v. Okay, so you can see that the equation of the line is given down here. Okay, this is what this line is. Okay, so we need to connect the two up really, and it's a simple bit of logs rules to get us to that. Okay, so I'm just going to copy this v equals p q to the t here. So we need to match these two up. So we're going to do the log to the base 10 of both sides of the equation. Okay, so log to the base 10 of v equals log to the base 10 of the whole of the right hand side. So just pop that in a bracket. Okay, now we're trying to reach this, and the most important thing is to see that we're with the left hand side we're already done. We've got log to the base 10 of v, that's what we want. So we don't want to rearrange this algebra, we don't want to change the left hand side. So log to the base 10 of v, copy that down, and we're just going to apply our basic log rules to this. And what we've got in the bracket is, at first we look at it, it's two things multiplied together. It's p times q to the power of t. Okay, so we should understand that we can split that, and it's two logarithms added together. So log to the base 10 of p plus log to the base 10 of q to the t. Okay, and then our other log rule that we use quite often is that this t can come down to the front here. Okay, so and once you get to this line, you should see that it looks a bit more like a straight line graph. Okay, and what I mean by that is that this is just a number, and then this is also just a number. So when you look at the right hand side, it is linear. It's a linear function of t. It's a number times t plus a number. Now, as long as we plot log to the base 10 of v on here, then this will be a straight line. Okay, now all we've got to do is match it up with this. Okay, so in this, the coefficient of t is 0.05. That's this bit here. So we can say that log to the base 10 of q is equal to 0.05. Okay, and then this number here, well, that's just this number on the end in this linear equation, 4.8. So again, we just write that out as an equation. Log to the base 10 of p is equal to 4.8. And now we just use the most important log rule to rearrange this in exponential form. Okay, then p is going to be equal to, well, it's 10 is the base, and then the 4.8 is the power. Okay, same with this one over here. We're going to get q equals, well, the base is 10. Okay, but the power here is just 0.05. Okay, and then you pop these in the calculator and see what you get. So p is approximately, well, they want it to 4 significant figures. So I got 63,095. That would be 5 significant figures. So I'm going to go for 63,100. And then q, I get 1.122018454. So 4 significant figures, 1.122. Okay, so this is your final answer to part A. So moving on to part B, we need to interpret the values of the constant P and the constant Q in terms of the model. And in this model, the V is a value of a rare painting, and T is time. Okay, and P and Q are just these constants that we've found. Okay, so if you reference the straight line graph, if we look at this point here, this is going to be log to the base 10 of V of whatever the painting is at t equals 0. So this is going to give us our value of the painting at t equals 0, but the log to the base 10 of that value. Okay, so we've already sorted that out. you know, that is basically 4.8, okay, on this graph. And then over here we've worked out what that is to give us an actual value of the painting. So P is the initial value of the painting. It's the value of the painting on this date here, the 1st of January 1980. Okay, so what is our interpretation for Q? Well, again, when you look at the straight line graph, it looks as if the value of the painting is going up, and the kind of rate that it's going up is going to be dependent on that constant Q. Now we got a Q of 1.122. That gives you an indication that, you know, it's a positive. Well, it's the gradient. If you look at the straight line graph, it's to do with the gradient, so it's to do with the growth of the value of the painting. Okay, not quite sure how they would probably want you to word that on the mark scheme. So in this case, I mean, if it's 1.122, a good way to interpret that would be that's around about a 12% increase. Okay, and then finally part C, it says find the value of the painting as predicted by the model on the 1st of January 2010. So 2010 is 30 years after the initial value, so you would be looking at the model and you would be plugging in a value of 30 here and coming up with a value for log 10 of V here. Okay, so we could put t equals 30 into this. Okay, so we're going to get log to the base 10 of V equals 0.05 times our value of t, which is 30, and plus 4.8. Okay, so pop that in our calculator, and then of course we can just use our simple log rule to get the value of the painting. It's 10 to the power of 6.3. And it says that we need to give our answer to the nearest 100,000. So we pop 10 to the power of 6.3 in the calculator. So I got 1995262 on the calculator. So to the nearest £100,000. So the £100,000 is the second digit. So actually to the nearest £100,000, we're looking at this digit, but because it's followed by a 9, we've actually got to take this up to 2 million. Okay, so the value of the painting is approximately 2 million after 30 years.